This conference will now be recorded.
All right, so just to give a quick recap of what things that we are doing out here is that yesterday we were getting into a concept called load balancing. We were understanding if you have multiple machines and you want to divert the traffic into those machines out there, how a load balancer can actually help you. And we were telling the different components of load balancer, like the front end IP. Then you have something called backend pools, meaning you can add multiple pools or you can add multiple virtual machine into your backend, let's say of the load balancer out here. And then you were telling something known as inbound rules, when you're telling how the traffic comes in and how should the load balancer actually divert the traffic into your backend pool, and what is the port in the backend that the load balancer has to divert this traffic and etc. And as a part of the inbound rules, we also configured a health probe, which will check the health of the backend, let's say pool, and divert the traffic accordingly, let's say into the backend of let's say your uh, of your virtual machines and all these things out. And we also did a demo on taking that IP, trying to hit that particular IP from different, let's say, browsers, and we were able to see that different virtual machines are responding. Virtual machine one responded, two responded, and all these things out. So this is the infrastructure that I have right now. Is that, let me go into the resource groups, and I have a load balancing RG. I have a demo RG also, and the demo RG contains multiple things like starting with the availability set. Then I have the disks of the virtual machine. Then I have the network interface cards. Then I have the network security group rule. Then I have the public IP addresses, the three virtual machines, a virtual network. And then in a different resource group, I have the load balancer and the public IP that is associated with the load balancer. So if I go into the load balancer, or even if you go into the public IP out here, it just tells you that this public IP is attached to what? The demo load balancer. So this is an IP that is attached to the demo load balancer. And if I copy this out, go into the front end and say default.html, I'll be able to see the response coming from multiple servers out here. So this is how the load balancer really works out here, and etc. Yes, any questions that I can take till here? Anyone, any questions that I can take till here? Any doubts or anything that you did not follow? We'll address that and then we'll move forward with the concept. Can you create a cross-regional load balancer? Good question. Yes, you can create a cross-regional load balancer also. In that case, it is called as a global load balancing solution. So we'll also look at that. It's called as a global it's called as a global load balancer, but that particular global load balancer is in a preview mode, meaning Azure has not made it really available for everyone. It's in a preview mode. It's called as a global load balancing solution out here, meaning, see, today, I mean, in yesterday's session, if I just have to present a diagram, I did something like this. I had VMs, let's say two VMs out here that are running in a region called ECS2. In your case, what you can do is that you can create another machine or another two machines, same application, running in, let's say, a different region called North Europe. Now what you can do is that you can go ahead, create a load balancer for this particular region, create a load balancer for this region also. So two regions, two different load balancers, and then finally configure something known as a global load balancer whose backend pools are regional load balancers out here. So for a global load balancer, you will have a regional load balancer, and these regional load balancers in the backend pool will have multiple virtual machines out here. This is the architecture that you can create for a cross regional load balancer out here. So when you do a load balancer, if I create a load balancer out here, let's say create, and let's give you some demo RG, something like this, say something like test LB load balancer standard. public internal, and let's go ahead and say this is standard load balancer, this is public load balancer, and you have something called global out here. If you select the global, it's now telling me, oh, fine, this is fine. The IP configuration of the global load balancer, and after the IP configuration, there's something called backend pool. So I'll just add this out. Let's say test, and this is, let's say, something like test IPA GLB global load balancer, and I'll say okay. In the backend pool, I can start adding, let's say, pool A. I can start adding my regional load balancers out here, the IP addresses of my regional load balancer. So if I have one more load balancer, I can go ahead and add that particular load balancer in a different region, and the inbound rules and everything is the same. But it's just how the configuration changes. For a cross regional load balancer, you will have to add regional load balancers in their backend pool out here. That's the only thing that changes out there. Yes, any more questions? Anyone, any questions with the entire setup of load balancing? Again, yesterday we were just doing a simple regional load balancer. So if I have to put the diagram here, I had three different virtual machines, VM1, VM2, and VM3, running out of an availability set. So I had something called as an availability set, and all these three machines were running out of this particular availability set, and the load balancing is managing the traffic that is going inside and out of this particular, let's say, virtual machines out here. This is how, let's say, this particular thing changes out there. Again, yesterday, if you all remember, uh, I firstly went ahead and I removed the public IP from all the three machines. So I said, you know what, you don't need a public IP. So when you create a virtual machine, you can create a virtual machine even without a public IP in place. But let's go back into our virtual machines. Let's go into VM1. It has a public IP again today. Go into VM2. Now let's observe the public IP here. What is the public IP? It is 20.190.208.220. Let's go into virtual machine 2. Same public IP, 20, 19, oh, 2190, 208, 220. Demo VM3, same public IP out here, which means whichever, and this particular public IP address, if you click on this one, is the IP address of what? The load balancer. So what really happens out here is that when you attach machines into the backend pool, they inherit the IP address of the load balancer. These machines inherit the IP address of the load balancer. Whichever machine that you add in future, let's say you go ahead and add a different machine out here into the backend pool, even that machine, if this, let's say, a load balancer has an IP of X, even all these machines will have an IP of X, X, and X. All these machines will inherit the IP address of the load balancer. This is how the load balancer will establish a parent-child relationship. Load balancer becomes a parent, and the backend pool become the children out here. This is how a parent-child relationship gets established between the load balancer and the virtual machines that are running into the pool out here. So let's go back. Meaning, whichever, or guys, please go on mute if you're not talking. Okay, thank you. So meaning, whichever machine that gets aligned to that particular pool out there gets this particular IP, and no matter which IP that you take, if you take the IP of VM1, just take the IP out here. Just go to your browser, paste this in, say default.html. Whichever IP you take, you will end up talking to the load balancer only, because this is the IP address that is assigned to your load balancer internally. So whichever IP you take, you'll let's say talk to the load balancer only. And if you don't like this particular IP address, you can assign a DNS name to it. Meaning, if I go back into the load balancer's IP, and into the configuration, there is something called as what? DNS name label. What I'll do, I'll say this is load balancer, something like this, dot east2.cloudapp.azure.com, whichever region that you are in. If you're in North Europe, it will say something called North Europe out here, and I'll just save this out. And what it will do is that it will now give you a unique DNS name. This one will have something called as a DNS name, meaning a website name, something called www dot something dot east2.cloudapp.azure.com, east2.cloudapp.azure.com, so on and so forth. Once you have this, if you go to the overview page, you have this link. You can now take this link, and instead of the IP, you can paste this link out here, and you can start interacting with your load balancer. Same page, but if I do /default.html, this will in return give me a response from the virtual machine out here. So you can either use the IP address of the load balancer, or you can either use the DNS name that is assigned to the IP address to of your load balancer out here. So anyone, you can go ahead and let's say start using this out, and all the machines will get the same IP and the same DNS name, same IP address, same DNS name also. Meaning when I deployed the load balancer yesterday, let's go back there and let's go into the resource group in which the load balancer is there. And if you go into the deployments, there was this Microsoft load balancer that got deployed. And do you see what is also happening? Firstly, it created the public IP address. Secondly, it created the load balancer. Third, it updated the NIC cards of my virtual machine. Why did it update the NIC cards? Because NIC card has the public IP address. So it went ahead, gave all these three virtual machines a public IP that is attached to your load balancer, and this is how the traffic is being managed. But the question here is that this is good enough. From a load balancer's perspective, this IP address is being given to let's say virtual machine 1, virtual machine 2, virtual machine 3, and whatever is there in your backend pool. Now let's say for a user, it doesn't really make any sense. I can just go here and this will go ahead, divert it to my load balancer. Load balancer will go ahead and divert my traffic to one of the virtual machines that is available. This is good from a user's perspective, meaning as someone who uses an application, I can just take that particular address, I can just go that, fine, not a problem. But let's say you're a backend administrator. You are an administrator that is sitting in the background, that is sitting inside the organization. And as someone asked yesterday, is that what if I want to now start, let's say, going inside the virtual machine 1 or 2 or 3? You have 3 virtual machines. I want to get some data. I want to get some particular log information. Then can I do an RDP into this machine? Yes, no? Sorry? You don't have the IP, but you have the IP, right? You don't have the individual IP. I removed the individual IP. That's correct. But if I go inside this one, I do have the IP address, some IP address, and this IP belongs to what? A load balancer. And also while creating this machine, I enable the RDP. The network security group rule has the RDP enabled, which means can I just take the IP of this particular machine, go to something like MSTSC or RDP, anything that you can type in. Even if you type in, there's a shortcut, this MSTSC out here. Opens RDP connection out here. Can I place the IP of a load balancer and can I give the ID? Can I do this? Because RDP is in each ways, let's say open, right? So I should be able to do it. But it's taking some time. Let us give it, let's say, a minute or so, and let's see how it responds. It is responding back. by a generic error telling that remote access to the server is not available, the remote connection is turned off, the remote computer is not available on the network. Why exactly is this is happening? Why do you think that this is happening out here? This is the IP of load balancer. So if it's the IP of load balancer, did you tell this IP which virtual machine that I have to establish an RDP on? This IP is given to all the three virtual machines. Did we tell which virtual machine I'm establishing, let's say, a connection to? No, not really. I did not tell. But if I use this IP over the internet, I'm able to communicate with one of those machines. Either, let's say, the virtual machine 1 or virtual machine 2 or virtual machine 3 out here. One of the machines I'm able to, let's say, go ahead and establish a connection to. Now, as a backend user, this is what I want to do. I want to use the same IP address of the load balancer, and I want to establish RDP connections either to VM1 or to VM2 or the VM3 out here. So I want to use the load balancer as my gateway to get into the virtual machine 1 or 2 or 3 as such up there. So what I'll do is I'll just go back into the load balancer, and I'll configure something called as NAT rules, network address translation rules. And I'll say go there, and these are the inbound NAT rules that I'm, let's say, talking about. I'll say add a rule, and in here I'll give a rule name called RDP hyphen underscore VM1, something like this. I'll say this is RDP VM1. I'll say this is the backend pool that I'm, let's say, talking about, and I'll say this is pool A, and this is the front end IP of my load balancer, which is 20.190.20220. And if anyone talks to, let's say, a port called 4000 on the front end, it can be anything, 4000, 5000, whatever it is. And now it's telling maximum number, that's fine. I will say, please divert them. Let's go back. Let's see. This is backend pools. This is this one. Let's say Azure virtual machine. Let's see this. Okay. Let's go into virtual machine directly. It's easier to configure. I'll say virtual machine. I'll say VM1, and I'll say this is the IP, which is what, 10.0.0.4, which is the private IP of my virtual machine. And I'm now saying that if someone goes to a port called 4000 on this particular IP address, then please divert them to a backend port called 3389, which is my RDP port out here. So what I'll do, I'm using my load balancer, and I'm using one of the ports of the IP address of my load balancer, some port of my IP address to the load balancer, opening a port and telling that if someone does an RDP onto this particular port called 4000 out here, divert them to a backend machine called demo VM1 at a port called 3389, which is already open in the background. So let's say already open in the background. So what I'll do is I'll come here and I'll put a port number called 3389, and I'll say add this out. So I am adding a rule called inbound NAT rule out here, meaning network address translation out here, which means that the load balancer in my case for a backend user is simply behaving as a translator between my computer and one of the virtual machine that is running in the background. And I'm now said that if this particular administrator user talks to you at 4000, please divert him to a backend port called VM1 at 3389, which is the RDP port of this particular virtual machine. And this RDP port is actually open. So if I now come back here, again, it will take about 1 or 2 minutes of time to, let's say, go ahead and create this particular rule. So any questions still here? Anyone, any questions still here? Online, offline? Let me see if I have anything in the chat. VM and load balancer can be in different, but in different. Okay, VM and load balancer can be in different RGs, but not in different regions. That's correct. VM and load balancers have to be in the same region. Only then you will be able to, let's say, go ahead and establish a connection with that. Yes. Any more questions here? Good question. We have to put three inbound NAT rules for three machines. Then yes, because this particular rule called 4000 is unique for a machine called what? VM1. So we have to put a rule called 4001, 4002 for different virtual machines, VM2 and VM3 out here. We'll also talk about that. So what I'll do right now is take the IP address of the load balancer because this is the only IP address that I do have. Again, I'll do an RDP connection, correct, indicating the VM1. Then how do I indicate it? Colon, using a colon 4000. I'm indicating on which port that I want to do the RDP on, and I'll say, let's say go here. I'll give the test user the username. I'll say connect. Now it's asking me for credentials. It's not failing. So let me give the credentials out here. Do you see what is this? Demo VM1. Again, I already have a machine open, so I'll just close this out. This is a different one, yes. And now I am inside demo VM1 using the IP address of the load balancer. So I am bypassing or I'm using the IP address of this particular load balancer out here as a translator to go ahead and start interacting with my backend virtual machines. So I will go here, interact with my backend virtual machines over a port called 4000 for VM1. Now if I want another rule for VM2, same thing. I'll go back into load balancer, add one more rule, and I'll say this is RDP underscore VM2, virtual machine is VM2, and I'll say IP address is 10.0.0.5. The IP address or the private IP address of that particular VM2. Front end IP, same IP address of the load balancer. Port is different. I cannot give a 4000. If I give a 4000, it's telling this is already allocated to VM1. You cannot give this, and I'll say 4001. Again, backend port 3389. Same thing for the VM2 out here. I'll say add this out. So now I'm adding the second rule. Again, it'll take like about a minute or so to add this particular rule. And I can also go ahead and add a third rule for VM3, VM4, and all these things. I can have multiple rules out here to establish connections with each and every virtual machine as such. So yes, any questions still here? Anyone, any questions still here on how do I add a rule out here? What is an inbound? I'm sorry. Which protocol? I'm sorry. See, that's fine. TCP is nothing but transfer control protocol. UDP is, let's say, unique defined protocol and all that stuff. But that's not really, let's say, comes into picture out here. Packets and all that stuff. It's just the data transfer packets out there. But in this concept, you can have any kind of a protocol, not a problem. You can have either TCP, UDP, whatever it is. It will work in the same way.
Hi, Kiran.
Good, please.
Uh, we have three virtual machines, and there is a in three virtual machines there is same data. If we
Hmm.
change in virtual machine one, the data will change in virtual machine two also.
No, it won't. The data will not change in virtual machine 2. You'll have to change the data. You manually go ahead and change the data in virtual machine 1 also. Virtual
Okay.
machine 1, 2, 3 are not synchronized with each other. They are three independent machines on which we are, let's say, manipulating the data out here.
Okay.
So then the question can be that, you know what, if I have really a working website now, it's a simple HTML page. I could just take like about 2 or 3 minutes to go ahead and change that particular HTML page. But when you're working with an actual development team, this small HTML page will be replaced by your actual website, your actual website out here. And in order to do a deployment onto your virtual machine, it will take a lot of time. And I'm talking about three virtual machines, meaning you have to go into each and every virtual machine, change the code into each and every virtual machine out here. Imagine you have hundreds of virtual machines. It's manually very impossible to go ahead, change in the first virtual machine, come down to the second, third, fourth, and all these things out. That's the reason we have DevOps in place. Now DevOps automates all this, let's say, code updates in a rolling fashion. That's where DevOps practice actually comes into picture. So as an administrator, it's very difficult for me to go ahead into all the machines out here and do all these things out. But as a DevOps engineer, I can actually just go ahead configure something called as a CI/CD pipeline, add all my virtual machines, then go ahead and deploy the code out there.